are not so. Okay, come back, Swivl. Thank you. Whoa. Okay, so what we're going to do, guys, is we're going to remember that concept. Just like with adding and addition and subtraction equations, multiplication and division equations have to stay balanced. So please don't forget that, because a lot of us, when we get to these kind of problems today, we forget to do it to both sides, which does make a difference. Okay, so the first one we'll deal with is a simple one. Right, you've seen this before. I want you to solve it algebraically. That means you have to keep it balanced. So how do I keep this balanced while at the same time getting an equivalent equation where x is all by itself? Man, that's a mouthful. Anna Grace?
Divide each side by 4.
Okay, why would I divide by 4? I guess, can you just like multiply both sides by 4? Here's the question. Are you allowed to multiply both sides by 4?
No.
Are you allowed?
Yes.
You are. Are you allowed to divide by 4? Yes. It would keep it balanced. But which one's going to get x all by itself? Dividing both sides by 4. Because what's 4 over 4? 1. What's 1 times x? And then 24 divided by 4. Okay, we say that x equals 6 is equivalent to 4x equals 24. They have the same solutions. Yes?
You multiply by 1/4, right?
You can multiply by 1/4. Yep, because dividing by 4 is the same thing as multiplying by 4. Yep, and you'll see that concept a little more in future problems. Okay, that was too easy. Let's go to this next one. I'll actually put it to the right of it. Negative 8.5. I hear stuff going back there, and I don't want to have to solve it during class. I want you to solve it, I don't want to help you solve it. You should solve it on your own. So please don't distract others back there. Okay, here's my equation. Negative 8.5 equals 5y. What is happening to y on that left side, or excuse me, on the right side? It's being multiplied by 5. What undoes that multiplication of 5? Either division by 5 or, Drew? What do you think?
By the reciprocal.
Multiplying by 1/5 on both sides. Remember, can you multiply both sides by the same thing? Yes. Can you divide both sides by the same thing? Yes. So which one should you do? It's up to you. Probably the easiest one, I think, is to divide by 5. And what'd you guys get?
Negative 1.7.
Negative 1.7. Don't forget, negative divided by positive is negative. And so that's my value for that. Why? I solved it. Okay, pretty straightforward. Let's go with this one now. Negative 5 3/8. Negative 5 3/8 is equal to 2q. Is equal to 2q. I'll try to make that little q very apparent. Okay, what do you do to both sides? You divide by 2 or multiply by 1/2. And you're like, okay, which one should I do? Well, first, I know that a mixed number usually is a lot easier when multiplying or dividing if I change it into an improper fraction. So what would this improper fraction be? Negative 43/8 equals 2q. So I just rewrote it. What would you do? Would you divide by 2 or multiply by 1/2?
Multiply by 1/2.
Okay, how many of you would divide by 2? It's okay if you would. You know what all of us end up actually doing? We're all going to end up multiplying by 1/2. Remember, stay, change, flip? So if you divided by 2, stay, change, flip means you're going to multiply by 1/2. So I multiply both sides by 1/2. That cancels that out. And make sure you can't cancel anything before you actually multiply. That helps you out. What do I get? Somebody? Yeah, there's?
Negative 2 equals 11. Or negative 2 and 11.
Okay, so did you get negative 43/16? Okay, and then you change it to an improper. On these answers, you can leave them improper. As long as they're simplified, that means there's no number that goes into both of them. Or they're reduced, you can also say. And then, sorry, what was it? Negative 2 and...
11.
So both of those are allowed, and they are equal to one another. In fact, I would say, dare I say this now, that this is probably the preferred answer. Does anyone know why I would prefer this, even though I understand that more? Why would I prefer this? And this is like kind of up to you. I don't know if you know. I just want to hear your thoughts. What do you think, Phil?
Because then it's like you need to multiply by it again.
Good. If you need to use it again in another equation or the same equation, if it were longer, more complicated, yeah, it's easier to deal with it that way. Good. All right. Okay, let's go. I don't know if I should say thank you or not to that. Okay, b over 11 equals 3. What's happening to b? It's being divided by 11. How can you undo that? Multiply by? Where do I multiply 11?
Both sides.
Both sides. Very nice. I need to see and hear both sides. And right now it may seem like, Mr. A, why do I have to do both sides? I know what happens when you multiply these two together. I know that happens. And I know you're left with that. But we will get more complicated, and you won't always know off the top of your head because you're going to do it multiple times. You just got to make sure you're doing it well. All right, 3 times 11 by 33. By the way, any of these problems, can they be checked?
No.
Yes, on that quiz on Tuesday, another reminder, you can check almost all of them, and you can see if you got them right or wrong. So hopefully you use that idea. Okay, what about this one that, you've dealt with before, but maybe you're not as comfortable with? 3/7 z, I'm trying to make that z clear, equals 36. Okay, which operation normally undoes multiplication? Division, right? Multiplication undoes division, and division undoes multiplication, all right? They undo each other. But what am I going to do here to undo the multiplication of 3/7? So I said they usually undo each other, but what can I do?
Multiply by 7/3.
Multiply both sides by 7/3. Both sides by 7/3. Don't forget, this is a common mistake. You always multiply by the reciprocal of the number that was being multiplied by the variable. So I'm not going to multiply both sides by 136. Do not do that. This is going to make it complicated. I'm going to multiply both sides by 7/3. Z equals, and then here, before you multiply, what can you do?
Cancel.
Yeah, you can cancel out. So 12 times 7. So Z equals 84. And if you were to put that back in, it would have worked. Sorry, I had a question. Okay. Oh, yes, sir.
If you can simplify that, 8 and 37. I mean,
3 and 30.
Over 3. Could you leave it as 262 over 3?
Okay, good question. You just multiplied 36 times 7, 1 times 3. That would be an unreduced fraction, and it wouldn't count. I'd take a point off.
So how do you know? How are we supposed to know if we're supposed to say?
Oh, what a great question. Ready? If when you are multiplying, there are common factors either diagonally, so these two numbers or these two numbers, or vertically, these two and these two, you need to cancel them out. So you really don't have to worry about simplifying if you did all that. See, I don't have to simplify anymore because I already canceled out common factors. I'm done.
But if we cancel out everything, we will still go into the improper fraction.
You wouldn't have to do anything. Yeah, let's say you got 36 or 12 over, trying to think of 12 over 5. 12 over 5 is fine. Good. So yeah, so cancel first. Just make your life easy. Okay. Let's go with this one here, which is written slightly differently. 2a over 3 equals 4/9. Okay. You need to understand something. This is my thought bubble. 2a over 3 is also equal to, so when you look at 2a over 3, it looks like a two-step problem, but it's actually a one-step problem if you could see a little bit differently. And was that you, Jack, who asked me about something like this? So I'm going to ask you, what would 2a over 3 also be known as?
2/3.
2/3 a. That's the same thing. How many of you believe me on that? How many of you can prove it? Just tell me how we know that, because I just said it, but I don't know if you can prove it. Drew?
2A and 2/3 A is the same thing.
Yes, that is correct, but how? Like, I mean, well, how can I just like take that A and move it off to the
You're
side?
allowed to in math.
Because of.
Because it's like, oh,
Go ahead, Phil. Okay, because. Can I show you real quick, or do you know? Will?
I was just gonna say they're both being divided by 3.
Okay, they are. These two are both being divided by 3, but like here, it doesn't look like they're doing that anymore, right? Okay, ready? Is this a multiplication problem?
Yes.
Okay, so what would you multiply here? 2 times A? Yes. 3 times 1? So it's the same thing, but you separated them. Why? I'm going to actually delete that and that and that. And that. And then I get I hope I get an easier problem. 2/3 A equals 4/9. All right, what do you do to both sides? Ellie.
Do you multiply by 3/2?
Why 3/2 and not 9/4? Hagen, why do I multiply by 3/2, not 9/4?
Because that's what A is being multiplied by.
You want to undo this stuff. You're not trying to undo that. All right. Now I get A equals, make your life easier here. Make sure I do that right. And then what do I get? A equals positive 2/3. Excuse me, it's so small. Bless you. You guys are too good at this.
You do that problem mentally.
It's possible, yep. Okay. K/4 equals 16. Just work it out. Not mental math. I want to show again, and on the test, as I was grading some of these problems, if you got the wrong answer, but I could see what happened, you didn't lose as many points as if you got the answer wrong and I don't know what happened. So I'm just trying to help you out on your test and on your quiz and on your homework and in math in general. Yes, sir.
I was gonna say the answer.
Can you tell me what you did?
I multiplied both sides by 4.
Okay, you multiply both sides by 4 and you were left with K equals? Okay, 64. Man, this is too easy. You want a tough one? Of course. Okay. Look at the top. Yeah, go to page 49. It's not a tough one. It's just more complicated. And you're like, wait, isn't that mean tough? No, it just means you need to be careful. It's cool. Speaking to our administrator, head of school, he's using this term called simplexity. Okay? Simple and complex at the same time. It's a complex problem with very simple parts all over. So if you can get all the little simple parts, the complex problem gets broken down. And when he said that to me, I'm like, that's math. Because, yeah, you look at the whole problem. Remember that number 12 on the test? It's like that's a huge problem. It's all these little problems put together. Put all those little problems, bring them together, and some of you got it right.
I messed up one.
Wait, the top of 49?
No, page 49, number 8 on the try these, number 8.
Oh.
I haven't given a problem yet, sorry. 49, number 8. Try these. Okay, remember if you have fractions and decimals in the same problem, make them all decimals or make them all fractions. And you can have either answer type. Yes, sir.
Number 8.
Number 8. Yes. You got an answer? Sorry. Okay. Oh, I forgot to say, oh, I'm so sorry. What do we have, 24 of you in here, students? So I don't mess up and say 24 and there's really 25. Anyway, 24 of you. I need 22 of you to get it right before we move on. 22.
What are we gonna move on to?
The next screen contains the information on what you're doing next. Okay. Am I being vague?
No, very clear.
All right. Okay, who's still working? Okay, I'll give you another 30 seconds. No pressure, but your class depends on you. And we have a timer now going. You guys can do it. I know you can. Okay, I think we're almost all done. The answer to this simplex problem is not 1, not 2, not even 10, but 5 plus 1, 6. Okay. 6. Yeah, sorry, the answer's 6. I didn't mean to confuse you. Okay. Do this if you didn't get it. If you didn't get it, just kind of do this. A thumbs down. Someone's like, I'm going to. Can you see that, Mr. Okay, I think all of you got it. So you get to move on. All right, here's what you move on. Congratulations. Show them what they've won. Oh my goodness.
Was it actually homework paper?
Yeah. Bless you. Swivl, we've made it through. With time to spare. Goodbye. Have a good weekend.